Hello friends, welcome to eVideoTuition. When it comes to the test automation development, oftentimes we are asked to provide the estimation for automation scripting. I was wondering to see if any standard solution or tool available for providing the test automation scripting. However, I could not find any scalable or the flexible solution over the internet. So is the reason I decided to develop my own model to calculate or find test automation scripting estimation. In this video tutorial, I am going to demonstrate you the model which I have created for estimating the test automation scripting effort. Before I jump into showing you the estimation model, I would like to also cover few more topics. The very first one is actually about the test automation scripting workflow. The next one is then test complexity, and then we'll talk about the estimation parameters, and the last topic is going to be the estimation model. So let's talk about the test automation scripting workflow. In general, and in many of the project, automation team receives the manual test case from the QA team, and the very first step is to analyze the test cases for automation feasibility. In this particular stage, we also like to execute the manual test cases manually to see whether there are any complexity or anything that would not be possible through the automation to achieve. So that analysis being conducted as part of the very first step. Then we move on to the second step, which is to identify the test data which we are going to use in the automation scripting. In some cases, we also need to make the test data reusable, and hence there is a need of identifying the pre and post conditioning, which is the third step of our workflow. The fourth step is actually to perform the automation scripting. That is a core task of performing the automation scripting, wherein we create the framework, we create functions, we put together the framework structures, file and everything in place to create the actual automation scripting. Once the automation scripting is done for the given test cases, we conduct a dry run. In dry run, we just make sure that the automation scripting which we have performed is actually running smoothly without any error. After the dry run, as part of the process, we should also be conducting a code review, usually done by the peer or your colleague of the same project. Then the last step is to updating the ALM and the GitHub. That is again the part of the process. Usually we also like to upload the test cases in ALM and updating the GitHub like a configuration management tool. So these are the basically multiple steps involved in test automation scripting. When we see the model, we will be saying the estimation for all these stages. Now, as we discussed in the test automation scripting workflow, the very first step is to analyze the test cases which we receive from the QA team. As part of the analysis, what we also like to do is to segregate or separate the manual test cases on their complexity. What we try to find out is to decide the complexity of the manual test cases, and there are multiple parameters to identify it. First of all, the test cases complexities are divided into three different categories: simple, medium and complex. And when we analyze, we try to see like how many transactions are involved, how many verification points are there, and how many steps in total there in the given test case. Finding out the number of these things, transaction, verification point and steps, will give us the idea of keeping the particular test case in the right bucket. So for example, if the test case has to be simple, the number of transactions should be less than 5, number of verification point should also be less than 5, and the total number of steps should be less than 15. So this criteria could vary from project to project, but it is the most recommended definition of simple, medium and complex test cases. But again, it depends, like in some project 15 step would still be I would say larger test case, and in some project 15 step could be simple. I have used the authentic source to come up with this test criteria. Now moving on to the medium complex and the complex one, that again varies from the category wise. So for example, in medium we should have the number of transactions or action involved from 5 to 15, and the number of verification should be from 5 to 10, and the total number of steps in a given test case should be between 16 to 30. For the complex one, anything beyond 15 and within 25 in terms of the transaction should be the complex one. Number of verification should be between 10 to 15, and the total number of steps should be between 31 to 50. And if anything crossing 50 is obviously a higher complex test case, and which is always suggested to split. If the test case is too complex, the recommendation of the industry is to split them in multiple logical flows so that the complexity of the test case could be reduced. I used Excel to create the model for estimating the test automation scripting effort. There are few parameters actually I kept in my mind when I creating the model. I wanted to create a model which is simple to use, scalable and flexible, so that for a different project requirement it could be tweaked and used. And hence I have used various basic formulas also of the Excel, so that any beginner of Excel also should be able to understand the model. Now there are few sections in the model, so let's first start with the input section. As you see on the screen, there are few input criterias in the input section. The very first criteria, as you see, is the tool complexity. When it comes to the automation, there are multiple tools available like UFT, Selenium, RFT. There are many tools available. For now, what I have considered is the UFT, Selenium and RFT. With every automation tool, I have actually counted or I have considered the complexity index. Since the UFT has been there in the automation industry for long, I have considered UFT as the baseline one, and I have compared the other automation tool with respect to UFT and tried to find out the complexity index. So as you see here, tool complexity for UFT is 0. 0 is the base value, which and the weightage of this parameter, and the weightage for every complexity index will start from 0. And then for Selenium, considering it is more programming intensive, I have included the complexity 20% more than UFT. For RFT, again the complexity is higher than Selenium and higher than, of course, UFT, so it's 30%. This parameter can be changed here. These are like flexible parameter. You can put whatever value you want here, okay, based on your experience, your project requirement. Now moving back to the input criteria again, the second one is the framework complexity. Depending on what type of framework you are using, whether you are using hybrid approach, page object model or any other type of the framework, you can actually select simple, medium or complex value, and each one has their own weightage in the parameter section, which is actually on the right side of the Excel sheet. So as you see here, the framework complexity is also having simple, medium and complex. And again, I have used some random value to categorize and put the weightage for each and every one of them. So if, for example, I'm using a medium complex framework, so I will go with the complexity index of 0.2. So likewise, we can select the value and then we can see the value being changing here. The next input criteria is about the application. This is very project specific. My application could be simple, your application could be very complex. So likewise, I have 3 values in here from the drop down to select simple, medium and complex, and based on your selection, the complexity index for the application will change here as well. Let me also show you how it does change. So see, I selected the value as medium. It is now changing the complexity index to 0.2. For complex, it is 0.4. Let me also make some changes here for tool complexity, so you see the changes coming here. As you see, it is now 0.2. Okay. Then the next section in the input is to find out the number of simple, medium and complex test cases. As we talked about, the very first step in test automation scripting is to actually analyze the test case for simple, medium and complex types. So based on our analysis, we should put the number here, and then we should sum up the total here in this case. So in my example, I am considering 100 simple test cases, 150 medium complex test case, and 100 complex test case for the automation. So yes, we talked about the input section, we talked about the parameter weightage as well, and these are all pretty flexible. If you want, you can change these values here. If you want to change the weightage of each parameters, you can make the changes here, and it will get reflected in the drop down here. Now let's talk about the model. So when we discussed about the flow of the automation scripting, we broadly discussed about the pre-script development, and script execution part. Okay, so the very first thing which we start with is the test analysis. For simple test case, I have considered 15 minutes. So what does that mean is, I am considering 15 minutes of manual 15 minutes of time for analyzing the simple test case, and I'm converting that value to hours, because I'm estimating the effort in hours. Okay, so I'm just dividing the 15 by 60, so it gives me the hours, and then I'm multiplying it by the number of simple test cases. You need to understand this calculation, because all the cell will have this calculation part. Okay, so let me explain this again. The C11 is the number of simple test case, 15 is the minute of 15 is the time that I'm gonna take for analyzing a single manual test case. Okay, likewise, when I move to the medium test case, it is going to be the D11, which is like a number of medium complex test case, which is in this case is 150, and for medium complex test case, the analysis time for a single test case is 30 minutes. Okay, and then for the complex one, it is going to be the 45 minutes. This is for a single unit. Now moving on to the point 1.2, which is about the test data identification. What I'm considering here is, again, like for simple test cases, I am assuming that I will need 20 minutes to identify the data for a simple test case. I know this is a bit higher for a simple test case, but we have to really find the right data so that we can use it over the period of time. So test data identification is basically a crucial exercise in many of the project. But again, it is a, if you think it is high for your project, or if it is low for your project, you can just make the changes here, and then you will see the value changing for the final calculation. And likewise, we have a medium test case. For medium test case, I am considering 40 minutes to identify the data, and for the complex test case, I am considering 1 hour for identifying the data. Alright, so we are done with the 2 steps, and the third step is to identify the data conditions. Now the data, we need to understand what data condition does. The test data identification will give you the data that you need to be using in the automation scripting, but there are some steps involved to keep the sanity of the data, so that you can reuse the data over the future run or the repeat runs. Okay, so you need to make sure that you are resetting the data once it is used in the execution. So those conditions, depending on your project, you should be identifying. For some project, it is like, for I can talk about my project. Okay, my project is a very crucial in terms of the data. So identifying the pre and the post condition is an important exercise in such project, and so is the reason that I have included this step also as part of the pre-script development step. Now talking about the minutes we require to identify the test data condition. For a simple, I'm considering only 15 minutes. For medium complex test case, I am considering it 30 minutes, and the complex one I am considering 40 minutes. Again, as I said, you can change the value for your project. These all values are flexible. I'm just trying to demonstrate the model that I have created, and this model is pretty flexible. You can change the value wherever you want, and you can see the value changing for the scripting effort in total. All right, so let's move on to the next segment, which is the core scripting part. In this scripting part, assuming that we have the automation framework ready, assuming that we have functions ready, assuming that we have our INI file or configuration file or our test data file ready, we are just talking of the core automation development. In this case, if there is a need of writing a new code, you will be writing that code. If there is a need of configuring few things, those also will be considered in here. Okay, so based on the industry norm, for a simple test case, I am considering 1.5 hours. For a medium complex test case, I am considering 2.5 hours, and for a complex test case, I am considering 3 hours for script development. Okay, then the last part is about the test execution. So when the automation scripting is completed, you always run the automation script, sometimes as a single or individual test case, or sometimes in a batch, but you execute it just to make sure that they are all passing and there are not any error in the code, automation code I mean. So you perform a dry run, and for dry run there is of course effort involved, though the execution is always automated, but of course when you are doing the execution, there is a manual effort involved. Okay, so that effort is what I have estimated for my project in this case, which is for a simple test case, it consumes 2.5 minutes. For a medium complex test case, it consumes 4 minutes, and for a complex one, it consumes 6 minutes of my time. So that's how I have come up with this calculation. For a code review, which is again an important exercise, and I recommend every project should have a code review before we commit anything in the GitHub or the ALM, which is actually the last step of automation scripting. So for code review, again for a simple, I have considered 10% of the scripting effort. So in this case, if I'm saying 150 hours for automation scripting, so I'm just considering 15 hours for the code review for the simple set of test cases. And likewise for 375, it is consuming 37.5 hours, and for 300 hours, it is just consuming 30 hours for reviewing the automation script. Last part is about and related to the process where we need to update test configuration tool, test management tool like ALM. This is process related part, but a mandatory step, and you should always be accounting this effort also in your scripting effort estimation. So in general, I have taken 15 minutes regardless of the complexity, because it does not actually depend on the test complexity to update the test case in ALM or in the GitHub. So for simple calculation and considering my project need, I have just considered 15 minutes per script to get them updated in ALM and GitHub. All right, so I hope you are all clear about the calculation. If you are not clear about it, I request you to go back and check when I explained thoroughly about this particular row, because I talked how the formula is being used in a detail for this row. All right, so when this all is done, and when you select the input criteria, when the weightage is correctly updated in parameters weightage, just by changing the number here, or if you want to change some parameters or the weightage here also, you can change. So the model will develop the effort in hours for simple set of test case, for medium complex set of test case, and for complex test cases. This is without considering the complexity index. Okay, so this is just a plain one. Considering that your project having some complexity index, it will also yield another effort which will consider the complexity index. Means this 278 hours will be multiplied by the complexity index, which is in this case is 1.6, and then that will give you the total effort for developing 100 simple test cases, which in this case is 444, and likewise for medium complex test case and complex test case. Then in total the model is gonna give you the total of both, or rather all simple, medium and the complex here in this case. And the last row is describing like how much time per script is taking to develop, or how much effort is being consumed by a single set of script in case of simple, in case of medium and in case of complex test case. Alright, I'm hoping you like my estimation model. I will upload the model in the shared portal, and I will share the link in the video description. You can download this model and you can start using it for your project need. I would like to hear the feedback from you all for the estimation model. Thanks for watching my video. If you like my video, please click on like button and share with your friends. You would also like to subscribe to my channel and visit my website for getting the latest update. Thanks again for watching.